Hello everyone. Today we will be looking at activity diagrams in UML. Myself, Vedant Vijay Bhamre. I am a final year student from the Department of Information Technology pursuing my engineering at Maratha Vidya Prasarak Samaj, KBT COE, Nashik. Let's proceed. So today we will be discussing about the introduction to activity diagram, its purpose, its various components, steps to draw activity diagram with some examples. First, let's begin with the introduction to activity diagram. Activity is a particular operation in a system. A whole system comprises of various activity, and to draw an activity diagram for a particular system, we must know all the activities that are performed by the system. An activity diagram is a dynamic diagram that shows the activity and the event that cause the object to be in the particular state. By performing which activity, how the operation and the system proceeds, we can dynamically visualize it using an activity diagram. The diagram describes the state of activities by showing the sequence of activities performed. Various states are need to be achieved while performing a certain tasks. And in an activity diagram, we will display all the stages that occur in performing a particular task. Activity diagram can show activities that are conditional or parallel. This is one of the plus point of activity diagram. Let's see. Purpose of activity diagram. Why we should use activity diagram. Activity diagrams are not only used for visualizing dynamic nature of a system, but they are also used to construct the executable system by using forward and reverse engineering system. Before building a system physically, knowing about all its activities is an important part, and activity diagram help us in visualizing the dynamic nature of the system, that how dynamically our system will be executed when various types of tasks are to be performed by the system. It does not show any message flow from one activity to the another. This is one of the most important point that we must consider, is that it don't show any message while transition from one activity to another. Let's now proceed to the components of activity diagram. First, initial or start node. This shows the starting point or initiation point of the flow, denoted by the solid circle. This is similar to the notation used for the initial state. As you can see, a solid circle is being displayed. This is the initial point or the starting point of our activity diagram. Final node. The filled circle with a border is the ending point. An activity diagram can have zero or more final state. This is the diagram using which we can show the final state in our activity diagram. Flow or edge. The arrow is used in the activity diagram to show the transition from one activity to another. Synchronization bar. It can break a trigger into multiple triggers operating in parallel or can join multiple triggers into one when all are completed. We will see the use of synchronization bar in the upcoming video. Activity. The rounded rectangle represents activity that occur. An activity is not necessarily a program. It may be a manual thing also. This is how we indicate activity in our activity diagram using this rounded rectangular box. Sub-activity indicators. The retake in the button corner of an activity indicates that the activity is described by a more finely detailed activity diagram. When we want to include much more details in our activity diagram, sub-activity indicators are used. As you can see at the right bottom of this box, that rake indicates that it's the sub-activity which is carried. A black bar, horizontal or vertical, with one flow ingoing into it and several leaving it. This denotes the beginning of the parallel activity. In simple words, forking means when a horizontal bar or a synchronization bar is having one flow going into it and several leaving the synchronization bar. This is termed as forking. Generally, forking is used when there are multiple parallel activities involved in the working of the system. Join. A block bar with several flows entering it and one leaving it. This denotes the end of the parallel activities. Joining is used with forking when we need to join several activities and giving a single output. Forks and joins. Now let's see how forks and joins work. At the synchronization bar, first fork takes place or branching out. In simple terms, we can define it as branching out in activity diagram where concurrent actions are taken place, and after these actions are performed successfully, they are joined and a single output is provided at the end of the activity diagram. Now let's move forward with decision diamond. Decision diamonds are used to describe the nested decisions where we need to choose, where we need to provide some conditions in our activity diagram. Decision diamond can be used. As you can see, the symbol where the both outputs indicate if and else to the condition we provide. Merge, a diamond with several flows entering and one leaving. The implication is that all incoming flow to reach this point until the process continues. In simple words, a process continues until and unless all the inputs to this merge are reached at this point. Decision and merge. This is how decision and merge works in the activity diagram. The decision node or the decision box is used to check the condition in the system, and if the condition is true, the action decided for the true condition will be performed, and if the condition is false, the action decided for the false condition will be executed, and then the merge node will combine their outputs and then final state will be achieved. Join versus merge. Now let's see what is the basic difference between join and merge. A join is different from a merge in that the join synchronizes two inflows and produces a single outflow. The outflow from join cannot execute until all inflows have been received. In other words, join will not give any output until and unless all the inflows to the join are received. A merge passes any control flows straight through it. If two or more inflows are received by a merge symbol, the action pointed to by its outflow is executed two or more times. In simple words, merge don't synchronize the inflows to it. It straightforwardly execute the output no matter how many times it receives the inflows. Suppose we have two inflows to our merge, then the outflow pointed by the merge will be executed two times. Swimline approach. To draw any activity diagram, we have two approach. First, traditional approach, and second, swimline approach. In swimline approach, a partition in activity diagram by means of dashed lines called swim lane. This swim lane may be horizontal or vertical. We will be looking to the example of swim lane approach in the upcoming video. Now let's see some examples of activity diagram. Let's take first example, ticket booking activity. Here is given an activity diagram for a ticket booking activity. The starting point, that is the solid black circle, indicating the starting of our activity diagram. And then comes the first activity, setup order. Then comes the decision diamond. Decision diamond decides the condition whether the user is having subscription or it's a single order. And depending upon the input type, it will be executed it will execute different type of activities. First, if the user is having a single order, it will simply assign them seats, charge the credit card, and mail the packets. And in second condition, if the user is having the subscriptions, it will assign the seats to it and debit the account and parallelly award bonus to the users who are having subscriptions. One thing we must note here that how synchronization bar plays the role in this and how concurrent activities are implemented using forking and joining. And after and in this joining, as we saw the difference between the join and merge, this part is join, where both the activities will be synchronized and then a single output will be transferred to this merge diamond. The merge diamond, as we see, does not synchronizes its input flow. Therefore, it will not depend on both the activities to perform. It will simply go on executing for the inputs it received. And finally, we reach to end of our activity diagram. This is one example. Let's see member activity. This is the activity diagram for the member activity. This diagram involves various parallel activities which are executed by user while he or she is signed in to his account. First, starting with the initial step, first activity login, then authentication, then verifying, and then after the user is verified and is logged in, the user can perform various activities as he wishes, like searching, partner alert, or changing its account, or online chatting, and changing passwords. And these are all the concurrent activities or parallel activities the user may perform. And all those are synchronized with the synchronization bar and joined to a single output. And after using the account, the user may log out. The user may log out and end its activity. Now let's move forward with our final example, the second approach of drawing an activity diagram, that is a swim lane diagram. Let me zoom this for you. This is an example of withdrawing an amount from an ATM machine. Here, as you can see, the swim lanes are divided into three parts, that is customer, ATM machine, and bank. The initial process starts with the customers. As you can see, it is indicated, the start point is indicated using the black solid circle. The first activity, inserting an ATM card. Now, as we can see, the second activity is denoted in the ATM machine. This represents that the activity performed by that role must be included in its lane. That is, as we can see, this vertical column, the validate ATM card, which is the activity performed by the ATM machine. So this activity is included in this. And after it, a decision diamond is included, considering the two possibilities, that if the ATM card is valid or not. And if it is valid, it will go to the customer lane and tell the customer to enter its PIN. And if the card is invalid, it will eject the card and the customer will take back its card and the flow of activity ends here. This is just one possibility that we are tracing, that if an user uses an ATM card and its ATM card is not valid, then how the ATM machine will end the flow. Moving forward, considering the second phenomena or second condition, that if the card is valid, then the user needs to enter a PIN. The bank will authorize the ATM PIN. As we all know, the ATM PINs are provided by the bank itself. So the verification of PIN will be done by the banks. And once again, taking the conditions in scenario, we use the decision diamond. If the valid PIN we receive, then the user is allowed for the further transaction. If the PIN is invalid, then it straight goes to the last merge box, and this merge box is then goes to eject card and then take card. One thing we must note in this is that how the activities related to the that roles are drawn in the respective lane. For an example, authorizing PIN is the activity carried out by the bank, so it is indicated in the bank lane. This type of approach is called the swim lane approach. Thank you for watching.